Bill wants to know if he can catch a disc at 30 meters if he starts running when the disc is thrown. Let's find out. First, let's determine the forces acting on Bill. There are technically 5 forces acting on Bill. 2 normal forces, one in the y direction from the ground and one in the x direction from the ground pushing back on Bill's feet, a gravitational force from the earth, a frictional force between Bill's feet and the ground, and air resistance. But we're going to ignore the last 2, friction and air resistance, for this experiment. Now let's set the upwards and left direction as our positives. First, normal force is in the positive upwards direction and is equal to the downwards negative gravitational force. Next, the applied force is in the positive left direction. Therefore, Bill accelerates in the positive left direction.
To find out if Bill can catch a frisbee at 30 meters after it's thrown, we need to find out how fast Bill can run 30 meters. On average, Bill runs 30 meters in 7.622 seconds. Now to calculate Bill's velocity, we do a simple calculation of the change in x, which is 30 meters, over the change in time, 7.622 seconds. So now that we have 30 meters divided by 7.622 seconds, we will get 3.96 meters per second. Therefore, Bill's average velocity throughout the 30 meters is 3.96 meters per second. Next, let's talk about the frisbee. We are looking at the frisbee after it has left Liam's hand. Therefore, there is only a gravitational force acting onto the frisbee. The gravitational force is in the negative downwards direction, and because of the gravitational force, the frisbee will eventually fall to rest onto the ground. Therefore, it accelerates in the negative downward direction.
By the time the frisbee reaches the distance of 30 meters, it has been 6.124 seconds.
We know the average time Bill takes to run 30 meters, delta t. We know our delta x, and we know our vi. Using these 3 givens, we can find our acceleration. First, we use the big 5 equation, x equals vi times delta t plus 1/2 a times delta t squared, and rearrange for a. Next, we'll sub in our givens and solve for acceleration. Based off our calculations, Bill's average acceleration is 1.03 meters per second squared.
To determine the force that Bill applies to the ground, we can use the formula normal force equals mass times acceleration in the x direction, using his acceleration and mass. Bill's mass is a whopping 120 pounds. We need to switch this to kilograms. This turns into 554.431 kilograms. With this calculation, we are able to determine his applied force, which is 56.216 newtons. Using Newton's third law, we can determine that the force he applies to the ground is equal to the force that the ground applies onto him.
Now that we have his force while not being able to catch the frisbee, we want to now determine the force needed for him to catch the frisbee. We already have his mass, and we want his acceleration to match the frisbee, which is 1.6 meters per second squared, by using our big 5 equation. We now sub this into the F net equals mass times acceleration. Therefore, the force Bill needs to apply while running is 87.3 newtons. Good work, Bill.